through this chapter 5. I would like to get through it before fall break, or before winter break, excuse me. So we'll see what we can do there. Okay, so let's start talking about triangles, shall we? Okay. So we need to be able to classify triangles, and we need to be able to say what type of triangle are we looking at. So when you look at a triangle, and you classify it, and you say, well, it's this type of triangle, or something like that, you might only say, well, it's an isosceles triangle, or it's equilateral, or it's a right triangle, or something. But really, if we're going to classify a triangle, we always have to say what type of triangle is it based on its angles, and then also what type of triangle is it based on the sides of the triangle. Okay, so you always have to be able to classify a triangle two ways. So let's start off with the easy one. Let's start the sides. Okay, so can you guys think of triangle sides? Like, what kind of triangle can you think of classifying something by its sides? Scalene. That's a word. What does scalene mean? Does it mean that the triangle has scales like a lizard? Okay. Close.
It's when none of the sides are the same.
Yeah, when none of the sides are the same length. When all three sides are different lengths, we call it a scalene triangle. Okay? So that's pretty easy to do. What's another one we can classify by? What's another word? Isosceles. Okay. The word that I've seen the most amazing spellings on the test that you can ever imagine. It's amazing how many different ways you can spell isosceles incorrectly. So isosceles, what does that mean if it's an isosceles triangle? Say it really loud. Everyone agree? Who agrees? You're all wrong. At least two sides are congruent. Now that doesn't seem like a big difference, but it actually is. And what's our other one is equilateral. Equilateral. Now equilateral means all the sides are congruent. Don't tell me all the sides are the same. Please, don't do that. So an equilateral triangle, all three sides are not the same side, are they? No, this side is not the same as this side. They're not the same side. They have the same measure, right? They have the same lengths, or they're congruent, we can say. So this triangle is equilateral, but it's also isosceles, because at least two of its sides are congruent. Now, no one ever knows that. Everybody thinks isosceles means two sides are congruent, right? And we always think isosceles like this. But we need to know that if it's an equilateral triangle, it is an isosceles triangle, okay, where two sides are congruent. And then scalene would just be where we have three different length sides. And usually they're marked differently like that. Okay, so that's it. Every single triangle is either scalene, isosceles, or equilateral. There's no other choices. Are there? Everyone roll your eyes up and look at the ceiling and think for a minute. Are there? Okay, not for sides. I agree. Okay, angles. So, acute. An acute triangle. What do you think?
All three angles are
All three angles are acute. Acute, meaning they're what? Less than 90? Are they also greater than 0?
Yes.
So is an acute angle between 0 and 90 degrees? Okay, not just less than 90. It can't be negative 40, can it? Okay, so an acute triangle is just something where all of the angles happen to be less than 90 degrees. Okay, and between greater than 0. This one, is it acute?
Yeah.
This one, is it acute?
Yeah.
This one, is it acute? Ugh. Is every triangle acute?
No.
All of our side ones were that I happened to draw. We'll have to take a look at that a little more closely. What about a right triangle? How many angles are right? Are you sure there's not two right angles in a right triangle? What would happen if there were two right angles? Yeah, they'd make 180 degrees, wouldn't they? And then what about the third one? Would it have to be 0? Can a triangle have an angle in it that's 0 degrees? No, so that can't happen. I just did that. We just did an indirect proof together. You're going to learn about that later. What about obtuse? Okay, one angle is obtuse. Can we say it that way? So this angle right here is between 90 and 180 degrees. Can it have more than one obtuse angle? Nah, that wouldn't work, would it? And then we have equiangular. I can almost forgive you if you forget what equilateral means, but if you forget what equiangular means, you may have had a hit injury. Because it literally says what? Equal angles, right? Can you forget what that means? It's impossible, right, Easton? We can never forget what that means. So we have equiangular triangle, so like this. Every single triangle is either acute, right, obtuse, or equiangular. Every one. There are no other choices. Right? Think. Look at the ceiling and pretend like you're intelligent for a minute. Anything? Can you come up with anything?
They don't have to be acute 60 degrees.
They what?
They don't have to, the angles don't have to equal 60 degrees.
Oh yeah. Let's talk about that. Let's talk about an isosceles triangle for a minute first. First of all, most of the time when we draw an isosceles triangle, we draw one that is acute like this. But it doesn't have to be acute. We can have a triangle that is an isosceles triangle, but it's obtuse. What about a right isosceles triangle? Is that a thing?
Yeah.
Yeah? Mason's definitely thinking that is a thing. We can have a right triangle that is in fact an isosceles triangle as well. So, there. Now, tell me, what do you guys think about the two angles opposite from the two sides that are congruent?
They're equal to each other.
Yeah?
Congruent to each other.
Yeah, they're congruent. Look, we have two congruent sides. Look at the angles opposite from them. Are they congruent? They're always congruent. In fact, in a right triangle, not only are they congruent, but we know what they are. What are they? Yeah, they're 45 degrees. They're 45 degrees right here. Okay? So that's always something that we can work out. So, you know, a lot of times you'll see something like this. They'll give you an isosceles triangle, and they'll just tell you this angle right here, and then they're like, find the measure of angle X. And a lot of kids will look at that and be like, I don't know. I can't. They've got to add up to 180, but I only know one of them. Right? But you guys are smarter than that, because you know that if this one's 30, what do these two have to add up to? What? That's right, they have to add up to 150. And so together, so each of them has to be 75 degrees. That's right, 75 degrees. So we can work that out. So anytime you know a triangle is an isosceles triangle, and by the way, this is the sneaky way to tell you it's an isosceles triangle. Give you something like that. Is that an isosceles triangle? Yeah. If it has two angles congruent, then it's going to have two sides that are congruent. Okay? And by the way, these are called the base angles. Base angles. The two that are congruent in an isosceles triangle, they are always what we call the base angles. Base angles. Base angles. The two opposite from the congruent sides. And this is called the vertex angle. Have you heard that before? Who's heard that before? Vertex angle. Yeah, a lot of us. Okay. Okay, so we've got classifying triangles. Yeah, it's a lot of words, isn't it? Is that shocking to us? Isn't this class just you learn what a lot of words mean and then you're good to go? I think that's what we do every day. In a coordinate plane, how can we classify a triangle? Let's look over on page 233 for a minute. Oh, top example 2. What the heck kind of triangle is that? Scalene? How do you know it's scalene? Are all three of its sides different lengths? Now they did the distance formula 3 times to show that. I think you guys could probably look at that and tell without doing the distance formula 3 times. I mean, sometimes they're closer. This one's pretty obvious, isn't it? What about classifying it by its angles? What kind of triangle is it? Is it acute? Is it right? Is it maybe a right triangle? Look at the slope of OQ. Can you guys find the slope of OQ? Of that segment? What is it? What? 1/2? And what about the slope of OP? It is -2? Okay. Are those two lines perpendicular? So what type of angle is that? Okay, so it's a right triangle then, isn't it? Okay, so we can tell that it's for sure a right angle right there, can't we? Because what do perpendicular lines form? Right angle. Okay, very good. All right, now, down to the bottom of the page, we talk about interior angles and exterior angles. When we look at a triangle, we're almost always concerned with these interior angles, like this, okay? But every polygon has exterior angles as well. I did this opposite color from the book, didn't I? Sorry about that. But if you extend one of these lines out like this, do you see our exterior angle right there? Okay? And you might think, well, what if I extended the other line out? Okay, see this exterior angle right there? Are they congruent? Same deal, isn't it? What about this angle right here? Breezy's calling. Hello. Yeah. Yep. Okay, thanks. Checking up on you, Chloe. All right. So what about this one again? Vertical angle, right? Okay, so it doesn't matter which one we extend out. Whichever direction you do it, try to be consistent. So, you know, if we bring this one out and look at that exterior angle, we bring this one out, look at the exterior angle here. Wait, which one we want to look at? That one? Okay, we want to have some consistency. So I'm going to draw my triangle. So that I can see the exterior angles. So I have an exterior angle right there, I have one right here, and I have one right here. Now they're not congruent or anything, but they happen to add up to a certain amount each time. Any guesses?
180,
180 is a dang good guess, because what do the interior angles add up to?
180.
180, right? Okay, but I want you to notice something with this triangle. As we look at angle 1, 2, and 3, they're all acute in this case, aren't they? Okay, look at the exterior angles. Are they acute? They're obtuse. Every one of them is obtuse, isn't it? Okay, so if they're all obtuse, they're not going to add up to 180, are they? No. Take a look at the tip of my pen here. So I'm starting facing this direction with the tip of the pen there. If I turn it that angle, then I come down here and I turn that angle, and I come over here and I turn this angle, what did the tip of that pen do? Yeah, it went all the way around, didn't it? So what is the sum of these three exterior angles? Okay, well, what if I had a different triangle? What if I have an obtuse triangle like this? So here's an exterior angle, here's an exterior angle there, there's an exterior angle there. Notice, so I have these three exterior angles. Are they going to still add up to 180 or 360? Notice here, when this one's acute, exterior angle, it's obtuse, isn't it? Okay. When the interior angle's obtuse, what's the exterior angle? Yeah. Okay, so it kind of balances out all the time. And this happens to be true for any polygon, regardless of the number of sides. So even if I had, let's say, a pentagon, if we start looking at the exterior angles, those 5 exterior angles, their sum is going to be 180. It doesn't matter what type of polygon it is. Now the interior angles, they add up to 180 in a triangle. They don't add up to 180 in the other figures. We'll talk about them later, but notice in this pentagon, how many triangles can I make? 3 triangles? All right, so the interior angles can add up to 180. So that's a good prefix for another lesson. Triangle sum theorem. Okay, so in a triangle, the sum of the interior angles is how much? What? What? Oh, yeah, that was terrible. 180 degrees, that's correct. I heard you mumble. Okay, so I've got these angles. I've got angle 1, I've got angle 2, and angle 3, and you guys say that their sum is 180. Is that correct? All right, can you prove that? Can it be proven? Or do we just think, yep, it must be that way? Man, your nose is so cute. Just hanging out all the time. I think I can prove it. So I just have this triangle. It doesn't matter what type of triangle it is. I'm not even sure if this one's obtuse or acute or what's the other choice, right? It's kind of close to all 3 of those, isn't it? It could be any one. Doesn't make any difference. But I'm going to prove that angle 1, 2, and 3, that their sum is 180 degrees. Have you seen this before? Who's seen this before? No? Well, gosh, you just been taking your teacher's word for it all these years? Let's draw another line in here. We'll call this line BD. And that gives me a couple angles too. We'll call that angle 4 and this angle 5. And this line, I didn't just draw it however. I drew it so that it's parallel to this side of the triangle. Now I could have drawn it parallel to any side of the triangle, doesn't matter, but I just drew it parallel to that side right there. Okay? So let's prove that the sum of angle 1 and 2 and 3, so we're going to prove the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees. So what are we given here? We're just given triangle ABC. That's pretty much it. Let's see, and let's see, and yeah, BD, that segment right there is parallel to AC. I think that'll work. Okay, so let's start off with this. I suppose we could start off with our given. Triangle ABC, and BD is parallel to AC. This is our given information. But I don't really need that to talk about this next thing. What do you guys think about the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5? Well, why? How do you know that?
Because it's in basically a linear pair on a straight line.
Yeah. Now we don't have a linear pair here, do we? No. But I think between our segment addition postulate and just knowing what a straight angle is, can we say that their sum's got to be 180? I mean, we know what a straight angle is. Straight angle and the angle addition postulate that just says that each individual one adds up to the whole thing, right? Okay, so their sum's 180. See where I'm going here? Anybody see it already? Why are these two lines parallel? Why did I draw them so they're parallel? What do you guys know about parallel lines and transversals?
Oh yeah, segment.
Ah, I don't see everybody looking up. I'm losing you. Come on. I know it's Monday. Here we go. Ready? What do you guys know about angle 1 and angle 4? So angle 1 is congruent to angle 4. What do we know about, what's the next one I'm going to talk about? Angle 3 is congruent to angle 5. Now, I kind of put those two together because there's the same reason. What's my reason?
Alternate interior.
Okay. Alternate interior angles theorem. Did you know you're going to have to remember that and use it to do other stuff later this year? Oh. Okay. I think I better say this too. The measure of angle 1 is equal to the measure of angle 4, and the measure of angle 3 is equal to the measure of angle 5. How do we know? Come on. Now, if they're congruent, their measures are equal. How do we know? Definition, yeah, there we go. Definition of congruent angles. Okay. Now let's go back. Let's go back to this thing right here. So I'm just gonna draw an arrow coming down here. See right there where we have angle 4, the measure of angle 4? What could we put there instead? Yeah, measure of angle 1 plus the measure of angle 2 plus, right here where it says angle 5, what can we put there instead? Yeah, the measure of angle 3. What did we use to do that? What's our reasoning?
Substitution.
Yeah, substitution property. Substitution property of equality. What do you think? Do the three angles of this triangle add up to 180? Do the three angles in the interior angles of any triangle then add up to 180? And it doesn't matter what type of triangle it is, does it? When you look at the triangle I drew, is that a right triangle? Could be. Is it obtuse? Maybe. Is it acute? It's possible. You know, if this angle right here is 89 or 91 or 90, it's close, right? And with any triangle that we draw, we can do this exact same proof. It doesn't matter. So every single triangle, the sum of the interior angles is 180. Okay, looks like I'm losing you at this point. So let's start on this assignment. Give it a go here, and then we'll talk a little bit more tomorrow. So chapter 4, 5.1. 1, 2, 6 through 36. Now, you're not going to get through all of this today in class, and you're not going to know how to do quite all of it yet, but that's okay. We'll talk more tomorrow, and we'll get you there.